Okay, so welcome back to part 2. This part will not nearly be as long. Alright, so what we're going to do is we are going to be solving some log equations. Alright, solving log equations. The thing you have to be aware of with logarithmic equations is you need to make sure that you check for extraneous solutions. Alright, remember those are kind of like fake solutions. You get the answer, but then if you plug it back in, it doesn't work. Alright, so you got to make sure that you do that. Alright, going into this, remember, when it comes to logs, the base must be non-negative. Alright, when you're dealing with the log, the base must be non-negative and not equal to 1, and the argument has to be positive. Alright, and the argument is positive. Okay, so that's something to keep in mind. We already kind of talked about that before. But if you get something where the base is equal to a negative number, then that's like an extraneous solution. So that's something to kind of keep in mind. Okay, so here's the first example. Alright, so this is example 3, part A. Let's say you have log base 3 of the quantity 4x minus 7 equals 2. Alright, what you're going to do is rewrite that in log, or not log form, in exponential form. And so you're going to do 3 to the second equals 4x minus 7. Okay, you get 9 equals 4x minus 7. You're going to add 7. You get 4x equals 16. So x is going to be 4. Alright, and double check, but if you plug the 4 in, you don't get a negative number because remember the argument has to be positive. So we're good to go. That one works. And you're done. Alright, log base x of 64 equals 2. Alright, rewrite that in exponential form. We'll have x squared equals 64. Normally you square root both sides and you'll have x equals plus or minus 8. Alright, but remember this is a base and the base can't be negative, so our only answer is going to be 8, not negative 8. Oh, and there's my clock in the background, sorry. Alright, C, we've got natural log of x minus 2 equals 3. So what we're going to do is we know that we have a base of e, so this would be e to the third equals x minus 2. And so then, depending on if you have a calculator or not, you could figure out what e to the third is and add 2. If not, like on the quiz per se, where there's no calculator, you would just leave it like this. This would be known as the exact answer. Alright, so the book will specify, and obviously on the quiz if it's non-calculator, that's about all you can do. Alright, D is the last one, and then we are done. So like I said, super short. E to the 2x equals 5. Alright, so this one's already in exponential form. Can't do much with it. So if you rewrite it in log form, it's going to have a base of e, so we know it's a natural log. Alright, natural log of 5 is going to equal 2x, right? Because e to the 2x equals 5. And then if you wanted to get x by itself, all you do is divide by 2. So you'd have the natural log of 5 divided by 2. All right, if the book tells you to round to the nearest thousandth, then you would plug that in your calculator. If you don't have access to a calculator because it's a non-calculator part of the quiz, then that's all you would write and you would be done. Okay, so yeah, that's pretty much everything with 4.4. Here's the homework guide, so you should be working on day 5, and the answers are on Canvas, and we'll go through questions tomorrow. Okay, so somehow my video got cut off, but you should be working on day 5 on the homework guide, and we'll go through any questions tomorrow. Thanks, have a good one.